Okay, guys, welcome back. Trig Algebra 3. So we are in the first unit. We're continuing on with the section R6. So make sure to locate this in your packet. So we're only going to do a tiny little portion of this section today because this, for some of you, this unit did not get hit in Algebra 2. So I want to make sure to take my time, not rush through this. So in this part, we're going to be simplifying rational expressions. A rational expression, you can see 3 examples below. It's typically just a fraction, okay, with variables on the top and the bottom. Now to simplify them, to simplify rational expressions, we're going to entirely have to factor the numerator. We're going to entirely factor the denominator. And then we're going to cancel any terms that are common. So let's take a look at the first example. The numerator. Remember, we always look out for GCF first whenever we're factoring. The GCF here is 3. Let me try that again. The GCF here is 3. And when we factor that out, that's going to divide to get 3x squared plus 2x minus 1. That can be factored further. We're going to carry down the 3. And then the trinomial right here, we can factor that into 2 binomials. We're going to use the guess and check method here. So the 3x squared can be split up into 3x and x. You know, think for the 3 here, 3 is a prime number, so it can only be composed of 3x and 1x. And then the signs, what do they have to be? Remember, when the c term is a minus, your signs are automatically plus minus. Now, this can be plus minus or minus plus. We're going to have to, when we get into our checking phase, this is going to play an important role. And then for the 2 terms here, the c term's a 1. So factors of 1 are only, obviously, 1 and 1, okay? So this guy, 1 times 1. So put a 1 here, put a 1 here. That's your only option there. To get a c term of 1 is 1 times 1. Okay, so now the check comes in. Now remember, we need to have a plus 2 for a b. And how we get at that is for the checking, it goes outside. You multiply the outside, so that would be negative 3x. You multiply the inside, that would be plus 1x, and then you add them together. Now, when you add them together, you get negative 2x, but we need a plus 2x. So that means my guess is wrong, so I can make a simple, I want to switch the signs and then guess or check again. So here, we're going to switch these signs. And we're going to try, instead of plus minus, we're going to try minus plus. So let's do our outside, inside, and add them. 3x times 1 is 3x. The insides, multiply them, they get minus 1x. And you add them together, and it's a positive 2x. And that matches with this guy right here. So that means my guess is correct because my check worked. Now, what I did right here for factoring that can be kind of difficult for you guys because the a term is not equal to 1. So if you need further instruction, just hit up YouTube and type in factoring trinomials, guess and check method. And you can watch further video on what I did there. So remember, guys, YouTube can be your best friend. if you're ever stuck on anything. Okay, so the numerator is entirely factored. Now we're going to move on to the denominator. So the denominator, do I have a GCF? Yes, I do. It's showing 12 and 12, so obviously you have a GCF of 12. Oh, let me move that up. Got ahead of myself here. So we got a 12, and then we divide by 12. So 12x squared divided by 12 is 1x squared, and then minus 12 divided by 12 is 1. Okay, so let's bring down the 12, but this, let me highlight it. This right here can be factored more. That's a difference of squares, which we learned a few sections ago. So difference of squares right there. You learned that also in Algebra 1 and Algebra 2. So if you need to brush up on difference of squares, just type that into YouTube. Okay, so now it's entirely factored. Nothing can be factored anymore and broken up anymore. So this gets to my last component of this. This is where we need to cancel or reduce common factors. Now, what I usually tell people is, bear with me here on my color tools. What I tell people is look at the normal numbers. You got a 3 and a 12. What would 3/12 reduce to? 3/12, each number would divide by 3 to get 1/4. Okay? Now we look ahead at the binomials. And if any one matches with any one at the bottom, if any one at the top matches with any one at the bottom, you cancel them. So right now I see some that match right here, matches with that. We will eliminate them. They divide each other and cancel each other out. Technically, when they divide by each other, remember anything divided by itself is 1, but we don't need to put the 1 there. We just cancel them out. And of course my cat bumped into me, knocked me off here. All right, we're back. Okay, can we cross anything else out? No. What's left over, the 3x minus 1 and the x minus 1, they are both binomials. We can't cross out any little parts of binomials. Like, people want to do this and this. Please don't do that. In order for binomials to cancel out, they need to be the exact same thing, which these are not. A 3x minus 1 is not the same as x minus 1. So what does that mean we have to do? Well, we bring them down into our answer. Okay, so I'm okay with you leaving this as an answer, but technically in the numerator where that 1 is, you don't really need to put that 1 there because that 3x minus 1 is there. So we can get rid of the 1, and if 3x minus 1 is the only thing up there, we can also get rid of its parentheses. So there's the answer to the problem. Now, even though we say these things, we are technically simplifying in these problems, I never promised that our answers would come out to be pretty looking, all right? That thing's pretty ugly. Okay, let's take a look at letter B, see what we can reduce here before we cancel some stuff out. Do I have a GCF in my numerator? Yes, I do. A 4 and 16. Definitely 4. Multiplies into both those numbers. Remember, the trick is you always look at the smallest number, 4, and you go, okay, 4 obviously goes into itself. Does 4 go into 16? Yes, so that means 4 is your GCF. Should I have an x with my GCF with that 4? Yes, those two terms at the top have x's in them. So it's actually going to be x squared. Remember, the rule for GCF with variables is you choose the smallest exponent. We have x cubed and x squared. Go with the x squared. Now we are going to carefully divide here. We're going to divide each term by 4x squared. So remember, when I say we're dividing the coefficients and subtracting the exponents. So 4x to the third divided by 4x to the second. 4 divided by 4 is 1. X to the third divided by x to the second is x to the first. But we won't put the 1 in front, and we won't put the 1 as the exponent. We'll just call it x. Then plus 16 divided by 4 is 4, and the x squared divided by x squared, that would just cancel out. So this top is entirely factored. X plus 4 does not have an exponent, therefore it cannot be factored further. Okay, what about the denominator? Do I have a GCF in the denominator? Yes, I do. 2, 6, and 8 would be 2. X is also common to all three of those terms, so go with the smallest one here. Go with the x. And now we're going to carefully divide by that 2x that we're factoring out. So 2x to the third divided by 2x, the 2 divided by 2 is 1. And x to the third divided by x is x to the second. Remember, we're subtracting 3 minus 1 to get the x to the second. Plus 6 divided by 2 is 3. X to the second divided by x is x. That's bothering me. That's the ugliest 3 in the world. I started writing a 2. Okay, and then minus 8x divided by 2x, so minus 8 divided by 2 is 4, and then x over x, the x's cancel. Now, let me switch colors. This trinomial can be factored further, so let's do that next. Let's bring the other stuff down. So my trinomial, we're going to break up into 2 binomials. It's a nice, easy trinomial this time around. So x and x. Look at your C term to determine your signs. Your C term is minus, so what are your signs supposed to be? When the C term's minus, it's plus minus. And then you need 2 numbers that multiply to get 4, and actually subtract to get 3. So is it going to be 1 and 4, 4 and 1, or 2 and 2? Now keep in mind the B term here is plus 3. So that would be this pair, plus 4 and minus 1. They multiply. 4 times negative 1 is negative 4, but 4 minus 1 is positive 3. So we're good there. Okay, so now it's entirely factored. So now we're going to look to see what we can reduce or cancel. So I tell people start with the normal numbers. You got 4 divided by 2 is 2. You don't need to put 2 over 1, just 2. Then, let me color code it for you guys. Then we move on to the monomials with the x's. X squared divided by x is x. Leave it at the top because that's where the bigger exponent is. Now lastly, we move on to the binomials. This, oh, I didn't mean to use the highlighter there. This cancels with this. Any binomial that matches on the top with a binomial on the bottom cancels out. So what's that leave you with? Well, that x minus 1 we're going to carry down into our answer. All right, I don't need that long of a fraction, so let me just make a shorter fraction. So there's my answer, x minus 1. And last one. This is going to get pretty tricky here. Now, the numerator cannot be factored at all. There's no GCF there. There's no other ways of factoring there. The denominator, however, That is a easy trinomial. So let's factor the denominator. So x and x. Our signs, the c term, we got another c term that's a minus, so signs are plus minus. And we need a b term that's a plus 1. So two numbers that multiply to get -6 and subtract to get 1. So your options are 1, 6, 6, 1, 2, 3, or 3, 2. Which of those with the plus minus gets a plus 1? It would be this pair here. A plus 3, then a minus 2. Okay, so this is entirely factored, but this is actually a very tricky problem. Look on the top how there's a 2 minus x, but at the bottom there's an x minus 2. We can't cancel those out yet. There's a trick here. Remember, it's like, is 7 minus 3 the same thing as 3 minus 7? No. 7 minus 3 is 4. 3 minus 7 is -4. So hint that one of them's a negative if you turn them around. So the trick is, let's write our fraction. We can turn this guy around to an x minus 2. However, what we have to do is put a negative in front of the fraction. So to turn a binomial around that has a minus sign, you need to put a negative in front of the fraction. Now you can notice that the x minus 2's are identical binomials, so now we can cross them out. So let's write our answer. Bring down your negative. You have x plus 3 on the bottom. What are you supposed to do if there's nothing left on the top? What are you supposed to write? You do not leave it blank. Remember, if you have a fraction that has nothing, if everything cancels on the top, you got to put a 1. So your answer is -1 over x plus 3. Okay, guys, we did 3 problems. It was rather long-winded. It took a lot of factoring and a lot of little trickiness to it, so definitely a higher difficulty here. But now that we did this, you guys should be good. If you look ahead on your assignment R.6A, you should be good. I just taught you how to do numbers 6 through 9. Okay, guys, have a great day.